All right, we have a lot of questions. What? Good thing you guys came in for help this morning, huh?
No games. Ciao. All right.
Do I have to apply that long rule to you?
No, I erased the A.
Among already second quarter, he couldn't bring his iPad to class.
But I wanted
Yeah, leading by example.
Can you just do all of
Okay, problem 5C.
I have parts A and B.
Wake the burger!
That's okay.
Okay, here's the velocity. 5 sine squared t cosine t from 0 to 2 pi. What does it say to do? When is it moving left, right? Find the displacement. What is the final position? Find the total distance traveled. Come on, this is what we did yesterday. So basically in this problem, you just have to do what I taught you yesterday. Find the displacement and then the total distance traveled. But remember yesterday I told you you can do both of the problems just by doing the total distance traveled. So the first thing you gotta do is you either gotta draw this graph or make a number line because you need to know when the velocity is gonna be positive or negative. So when is sine equal to 0? When is cosine equal to 0? Okay, so did you guys make a number line?
Yes.
Okay, read it off.
Positive, negative, positive, negative.
Ah!
Negative.
Wait, let me look at
I
this.
did it wrong.
What does it do? Negative. Negative, but that's correct right there. So that means you have to make integral from 0 to pi over 2 of the velocity dt because the particle is moving to the right here. And then you can just do 1 from pi over 2 to 3 pi over 2. Right? Because negative, yeah? So of the velocity dt. And then you have to do an integral from 3 pi over 2 to 2 pi of the velocity dt. Now the question is, how the heck, I'm going to put the velocity here. I'm going to throw a 5 on the outside like an unwanted pet. Yeah. How the heck do you do this integral?
You substitute.
There you go, u substitution. You guys should be experts at that. So, if you let u equal what? Sine, no, just sine t, yeah? So that you get u squared. And then du is cosine t dt. We still gotta know u substitution. You gotta know everything. Just wait till we get to 8.3. You guys. Anyway, 5 u squared, and then the du is the dt. But what are the new limits of integration? If I plug in 0 for t, you get 0. If I plug in pi over 2, you get 1. So that comes out to 5. What's the antiderivative of u squared? Is it just u cubed? No, with the 1/3 in the front, from 0 to 1, factor out the constant, and then you got 5/3 times 1 minus 0. That's 5/3. So this first integral is 5/3. Now, since the integral is going to be the same, we don't want to reinvent the wheel. What's the only thing that's going to change here? You're still going to do a u substitution. What's the only thing that's going to change? The limits. So we can just go from right here. 5/3 u cubed. And what are the new limits going to be? If I plug in pi over 2 right there, what do you got? 1. If I plug in 3 pi over 2 right down yonder, what do you got? Negative. So you get 5/3 times plug in the top number, -1, minus plug in the bottom number, 1. You got negative 10/3. Hey, how come that answer came out negative? Is that right? Yes, it's supposed to come out negative because look, the velocity is negative. The graph is below the x-axis. It has to come out negative. And then finally, this last one, let's not reinvent the wheel, so just go to this step right here. 5/3 u cubed from, what are my new limits going to be? Plug in 3 pi over 2. -1, and then plug in 2 pi. 0. So that's 5/3 times 0 minus -1, and that's equal to 5/3. So once you do all this, you can answer the question. A, what is the displacement? You simply add these numbers up. Rhymes with hero. 0. To find the total distance traveled, you simply add the absolute value of these numbers up. 20/3. But then we didn't really answer the question, yeah, because didn't part B say if the initial position of the particle is 3, what is the final position? Well, look, here's your number line. If you started at 3 and your displacement is 0, that means you're at the same place you started with. What's the final position? 3, right? Come on. So, the hard part, this is the hard work. This is the grunt work that we gotta do right here. You guys don't like that yet. You're gonna, I guarantee on the first quiz, am I giving you a practice quiz again?
Yes.
It's probably gonna be almost exactly the same as the example we did yesterday. That's okay, Mr. Park, because I don't keep up with the homework, so if I do the practice quiz, I can do good on the quiz. You don't think I know what you're doing? 10A. 10A, a particle. Now, how do you know if you can use a calculator or not? Do you guys even know?
Let's use it
Where? Where does it say min?
a little bit on the assignment sheet.
Oh, then what's the problem? Then if you can use knit my dog, well, sometimes his paws just has a hard time pressing the buttons.
Yeah.
Come on.
I did
It says from 0 to 4. What is the? Are you kidding me?
Integral from 0.
Okay, look how easy this
For
is.
A.
How do you end this?
How do you enter this on your calculator? Okay, what integral represents the displacement? The integral from 0 to 4 of t minus 2 sine t dt. Okay, when you take the AP exam, this is what's going to happen. You write the integral, you get 1 point. You compute the integral, you get the other point. So just punch that in on your calculator.
I did.
Except you use x, not t.
Is it in the right mode?
Are you in radian mode?
Oh.
That's like the first thing you should check.
Oh,
okay?
that's why.
If you have a trig function, you have to be in radian mode, otherwise lose money. And then what about for part B? How do you find the total distance traveled? You integrate the absolute value of the velocity, dt. And did you guys practice putting the abs on? Because you're going to have to do that on the next quiz, you know. The abs.
Yes.
Options, number, and then abs is right there.
I calculated the zeros.
But I remember yesterday I told you guys.
Yeah, I forgot.
If you want to, you can, and it came out the same though, right?
Yeah.
But then look, you just punch it in and boom, the answer comes out, just like eating strawberry Pop-Tarts. Just comes out. 15.
I had one for I think everything.
Actually, it doesn't matter what you eat, it's coming
Yeah,
out.
everything
15.
Oh, that's what you.
I've been saying that. I've been saying that the whole year, Mario.
We thought you meant like it comes out of a toaster.
What?
If that's what you call a toaster. Okay, we have to look, in problem 15, we have to look at the picture they drew. Okay, here, this is time versus velocity. So this is the velocity. They give you a picture like this. And these areas are 4, 5, and 24. And this is A, B, and C. Okay, so number 15 says, approximately, where does the particle achieve its greatest positive acceleration from 0 to B? Now, if this is the graph of the velocity, what is acceleration? The derivative or the slope of this graph. So from 0 to B, where do you have the biggest slope? Yeah, right at A, look at that. Boom.
So, does your answer have to be one of the given letters because those are the only points
Yeah.
that you're given? Oh, okay.
See how it's like, that's the biggest positive slope you have, right? So you're just basically looking at the graph. There's nothing to it, really. Number 19, they give you a graph. Oh, hey, this looks like a physics problem right here. This is exactly the kind of problem you got in physics. Here's the velocity. So they give you a graph that looks like this. Wonk, wonk, ink, there. Okay, I'm not going to draw all the thingies in. So what does it say? The graph of the velocity is given, where is the particle at the end of the trip, and find the total distance traveled. So what you need to do is you need to compute these areas. Okay, I'll do it. Number 19. What is this area? No, you guys are gonna do this. You guys,
-1.
I call your name, you give me the number. Hazam alam.
-1.
Area cannot be negative.
Oh, 1.
1 then, okay. Trapezoid, Morioka. See if I can do this in my head. Okay, I got my answer.
I think I said 4, but I'm not sure.
I got 5.
Yeah.
Right, because the area, what's the formula for a trapezoid? 1/2 the height is 2, right? So 1/2 times 2 is 1, and then you just go b1 plus b2, so that's 4 plus 1 is 5.
Hey, Mr. Park, how come on the graph, like the line isn't just before 5?
That's just your eyes playing tricks. It should be 5. Otherwise, you can't really do the problem, that's why, yeah.
Okay.
Yeah, you gotta, and then, what is this area here, Bailey?
1.
Oh, you think you're good, huh? 1/2, 2 times 1, that is 1. Okay, now we can answer the question. What is the displacement? So it's like -1 plus 5 plus -1, that's 3. But you gotta, that's the displacement, but you gotta answer the question now. It says the initial position is 2. So if the displacement is 3, that means you ended up 3 units to the right of where you started.
Wait, that's confusing because if there's a y-axis, then that means the y-axis isn't going through 0, it's going through.
There's no y-axis, there's a b-axis.
Oh, okay, okay.
Wait, what's confusing
Never
about
mind,
this?
I get it. Sorry.
No, what? Okay, never mind. And then the total distance traveled, you simply add up these numbers, the absolute value of these numbers here. So 1 plus 5 plus 1, the total distance traveled is 7. Come on, that's right out of physics A right there. Okay, 34. Hey, you guys got the milk carton problem. Very good. I told you guys were gonna get the milk carton problem. 34. Oh, it's multiple choice. Come on, 1 out of 5 chance.
Oh, I get that. That's a lot of adding. Yeah.
Okay, 34. You know what? I'm gonna rewrite this chart here. Oh, this is the acceleration. Oh. 0, 3, 6, 9, 12, 15. Oh, they're all equally spaced apart. That makes it even easier. 4, 8, 6, 9, 10, and 10. Okay, it says a car, if the initial velocity is 5 feet per second, which of the following gives the approximate velocity at t equal 15 using the trapezoidal rule? Now, look, if this is time versus velocity, what does this area represent? Displacement. So, what would happen if you have time versus acceleration? What is the area going to represent? The accumulated velocity, right? It's like the same thing. So, I mean, I was hoping we wouldn't have to, if you need to draw the picture, then draw the picture. So here, 3, 6, 9, 12, 15. Plot the points, 4, 8, 6, 9, 10, 10. So you have a function that kind of looks like that, yeah? How can I approximate this area? Well, they want you to use trapezoid, so ponka, 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 ponka. So if you add the area of these trapezoids up, it gives you an approximation of this area, which represents the accumulated velocity, right?
Yeah.
Okay, so the base of each trapezoid, look, it's all 3. It's all the same, it's 3. So 1/2 the height, let's factor that out, and then all you have to worry about is B1 plus B2. So for the first trapezoid, what is B1 plus B2 right there? 4 plus 8. Oh, you guys think you can add numbers? I'm just going to write it out, 4 plus 8. Next trapezoid, 8 plus 16, and then 6 plus 9, 9 plus 10, and then finally 10 plus 10. There you go. So if you compute this number, this is an approximation of this area, which gives you the accumulated velocity. So I think we need to compute this to answer the question. Let me see if I can do this. 12, 14, 15, 19, 20. So if I were me, I would add the odd numbers first, 34, and then add the even numbers, 46. So that comes out to 80. Is that right? So that's 120. Is that what you guys got?
The answer is 125.
Yeah, that's because you gotta
At the
read,
initial position,
you gotta read, it says the initial velocity is 5. So that means at the very beginning, your velocity is 5 feet per second, but then you accumulated 120 more, so doesn't it make it 125? Yeah, you gotta read carefully because is 120 one of the answer choices?
Yes.
Yeah, they would have snagged you right there. No, I remember, this was like 5 or 6 years ago, this problem. And it snagged a lot of people. You know, when they give you an initial condition, like, oh, the initial velocity is 5, there's a reason why they give it, you know? Because you're probably going to use it in the problem. 35. Multiple choice. Pollution, oh gosh, I need glasses. Is being removed from a lake at a rate modeled by this function, 20 e to the negative 0.5 t power in tons per year, where t is the number of years since 1995. Estimate the amount of pollution removed between 1995 and 2005. Come on! If you are given a rate, how do you figure out how much was done? We talked about this here, just like the water flowing out of a pipe.
Integrate.
You integrate it. So you integrate this thing dt, because what are the units of this? What's the gap? Let me look again. Tons per year. If I multiply that by a unit of time, which is year, what is tons per year times year? Tons, and that's what you want. How much pollution was removed? So you simply do an integral. Anytime you're given a rate, you want to find out how much was done, you do an integral. And what are my limits of integration here? So should I go 1995 to 2005? No, because it says t is the number of years since 1995. So 0 to 10. And we don't really need a calculator for this one, but what the heck, just punch it in the calculator.
Oh, it's okay.
Because we can do the antiderivative of this, right?
Yes, we can.
Yeah, but you know what? Just use your calculator, options, calculus, integral, and then get the answer. The main thing is you can set up the integral. And then 36, that was 36, we're done.
No, 35.
Stop yelling at me. So this was 36, this is 35. Oh gosh. The rate at which customers, see I told you, yesterday, remember I told you there's gonna, on the AP exam they had, people are arriving at an amusement park at a certain rate. This is the same thing. Customers arrive at a counter at this rate, 12 plus 6 cosine t over pi. For 0 to 60, to the nearest whole number, how many customers arrive at the counter over the 60-minute period? Well, if this is the rate at which customers are arriving, how do you figure out how many customers arrive? You integrate this from 0 to 60. And we don't need a calculator for that one either, but what the heck? Just punch it in your calculator. Because these look like, I mean, come on, I've been teaching this for 30-something years. Yeah, so these all look like calculated problems you're going to see on the AP exam. The main thing is you got to set up the integral. Sometimes you're going to get a calculator, sometimes you got to compute it by hand. All right, today we go on to 8.2, computing areas. Now, the problem every single year in this chapter is students cannot draw the graphs. So, the beginning problems in tonight's homework, they're going to give you the graph. And then after that, you got to draw your own. And that's where the, no, you draw it by hand. Not you graph it on a calculator. No, this is, okay, let's start off with a simple example, and then we'll kick it up a notch. Yes, we have to. Compute the area bounded by, okay, let's start off easy. Y equal x squared, no! y equal root x and y equal x over 2. Yeah, I like that better. Compute the area bounded by these two graphs. Now, do you guys understand what bounded means?
Yes.
You sure?
Yep. Yes.
Because every year they say that and then on the test all hell breaks loose. Bounded means enclosed by. So what does y equal root x look like? That's a base graph. You're supposed to know that. Swing!
There you go.
That's what I thought. And then what about y equal x over 2? That's a line. Slope 1/2. Swing! Okay, but in order to do this problem, you have to find the points of intersection. Now, of course, if you graph it on your calculator and then g-solve the intersection, yeah, you're going to get it, but you're not going to have a calculator. Because this is on the no calculator section. So obviously this point here is 0, 0. Now, to compute this other point, there's two methods. One is, you can solve these equations algebraically,
Yes.
or you can guess and check.
It's 4. Oh, it's 4. X equals 4.
Now, some of you are not that skilled at guessing and checking, yeah? So this is, okay, if you have problems guessing and checking, try plug in, if I plug in 1 here and 1 there, you get the same number. But what about 2, 3, 4?
Yes.
Bingo, there you go. That's guessing and checking. 4 comma 2, right? Because if you plug in 4 into both of them, you get 2. Now, lots of times it's going to come out nice, but what if it doesn't come out nice? What if you can't find it? Then you got to set the equations equal and actually solve it. But I don't care how you do it. See, this is easy because there's no trig. Wait till you get the double angle ones and things like that. Okay, now how do I compute this area? Well, there's two ways to do it. One, what if I were to draw a vertical rectangle like this, infinitesimal width? What is, okay now, what is the area of a rectangle? Isn't it length times width? Or base times height? Okay, what is the height of this rectangle? How do I measure this height?
The difference in this one.
Yeah. Okay, here, let's go back to elementary school. If this is 2 and this is 5, I think I drew this before, yeah? How do I know this is 3? 5 minus 2. Top minus bottom. Big minus small, and that guarantees it's positive, right? Because a distance cannot be negative. And same thing, what if it's a horizontal distance? What if this is 1 and this is 7? How do I, wait, this is 1 and this is 7. How do I know this is 6? Right minus left. Big minus small. That guarantees it's positive. And you know what they say every year? Mr. Park, what if you're like negative numbers though? What if this is negative 2 and negative 6? How do you know that's 4? Top minus bottom. Big minus small. Doesn't it come out to 4? So you always have to subtract so that it's a positive quantity. So let's go back to this problem. Now, can you see that the length of the rectangle changes as you go? Like over here it's small, but then now it's getting bigger, and then now it's getting smaller again. It changes. So what is the length of the rectangle? Top minus bottom. What's the top? Y equals square root of x. It's the square root of x because it varies. It changes. It doesn't stay the same throughout the interval. It changes. That's why you're going to have a variable there. What is the bottom? X over 2. So you, in other words, you have to know which graph is on the top and which graph is on the bottom. Otherwise, you're done for. Which means you have to be able to draw the graph. So right there, top minus bottom, that represents the length of this rectangle. What is this infinitesimal width right there? We talked about this yesterday, remember? I heard one person say it.
Yeah.
It's dx. That dx means something. It not only tells you what your independent variable is, it represents this infinitesimal width. Like I told you yesterday, like over here, look. What did we, in science? That's a change in x, delta x. But when it's infinitesimally small, we call it dx. Kind of looks alike, yeah? So, length times width. Hey, that's the area of this rectangle. So if I want to find the area of this entire region, I'm going to add up all of these rectangles. That's what an integral does. It adds up an infinite number of things. Notice I didn't say rectangles, I said things, because later on we're going to add up an infinite number of other things. Okay? So we're going to add up all of these rectangles from So should I go 0 to 4 or 0 to 2? Why 0 to 4? Because of this. If you're doing the integral in terms of x, you go from the x coordinate here to the x coordinate there. So that's what an integral does. It just adds up all of these infinitesimally small rectangles, right? Because you know, right, when you did LREM, RM, and MREM, and trapezoidal rule, the more you add up, the less error you have, right? So if you add an infinite number of them, you will get the exact number. So what you need to learn how to do tonight is you got to learn how to set up the integral. Because now the second part is now you can solve it. Hopefully this is the easy part, because we should be experts at computing integrals now. So how do I compute this one? Do I have to use any exotic or even erotic technique? No, because both of these are on the list. So what's that? That's x to the half, so what? Make the power 1 bigger, put the reciprocal in the front. And what about that?
That's x 1/4 x squared.
1/4 x squared from 0 to 4. How come I don't put the plus c? Because they're going to cancel out. This is a definite integral. Plug in the top number. Okay, this is where you guys have trouble. 4 to the 3/2 power.
16 over 3.
Okay, 60. Well, you guys think you're better than me, huh? Plug in top here.
4.
4 minus, plug in the bottom number, 0 minus 0. And so the 4 is 12/3.
Turn phone.
That's you!
Yeah.
You're out!
Okay. Sending my phone though. Turn phone.
Oh, sorry.
Kevin, it's all your fault.
It's all my fault.
Super loud, Rachel.
Who are you anyway?
Who am I?
What's your name?
Jensen.
Jensen who?
Cheng.
I heard of you.
You probably also had my brother.
Who's your brother?
Tomar.
Oh yeah, I remember your brother.
Is that a good thing or a bad thing?
No, he was good. Anyway, so the final answer is
On video.
4. So that area is exactly 4/3 square units. Okay, but now I'm gonna show you something. So, Mr. Park, so do you always make the rectangles vertically like this? No. Sometimes you have to make the rectangles horizontal.
Oh, then it's
What? Okay, so here, let's take a look at this. No, in some problems you have a choice. You can pick one. Like this problem, you can use either. But some problems you're kind of forced to do it one way. So you got to learn how to do both. So let's redraw this picture. So here's the point 4, 2. Now, what if you make the rectangles horizontal like this? Can I compute the area of this region still? Yeah. Except, how do you find the length of this rectangle if it's horizontal?
Big
Right minus left. You gotta go big minus small. Right minus left. But when you do that, see how the equations are written in the form y equals y equals?
Rearrange them.
So if I'm gonna do it that way, you gotta change it to x equals. So this line now, if you solve for x, is x equals what? 2y. And then, if you solve for x in this equation, you're gonna get x equal y squared.
Wait, what?
Because you're gonna do the integral in terms of y, so that's why you have to solve for x. Just like over here, the equations were given as y equals, right? Because you're doing it in terms of x. So it's just like, you're just doing the opposite thing.
Then just do dy.
Exactly. Okay, so how do you find the length of this rectangle?
2y.
Right minus left. 2y minus y squared multiplied by the infinitesimal width. Now, how come the width in this one is dy?
Because the up and down is a small part.
Exactly. This is a change in y, but when it's infinitesimally small, it's dy.
I have a question.
Mhm.
How come it's 2y minus y squared?
Right minus left.
Always.
Like right here, right?
No matter what.
If you do a horizontal rectangle.
Okay.
Left minus.
No, right minus left.
Oh, okay.
Look here, look. I'll do this again. If this is 1 and this is 7. Oh, it's 6. right minus left.
It's on video.
Can't see the rubbish can on the video. So for those of you who still didn't get it, look, when you draw a vertical rectangle like this, see the infinitesimal width is dx.
Yeah.
But when you draw the rectangle this way, then the infinitesimal width is dy. It's a change in y, except infinitesimally small.
That's amazing.
And then you're gonna add up all of these rectangles from
0 to 2.
0 to 2. Okay, very good. You waited till the valve finished ringing. That's what you're supposed to do.
Sorry.
And so, if I compute this, Mr. Burke, should I get the same answer?
Yes.
Yes! Because you're just computing it in a different manner, but it's the same area, right? So let's see. I'll just stop talking for a while. Yep, you get the same answer. And you should get the same answer, right? No, I have plenty, thanks. Oh, because I gave you last year, yeah? Well, you're reciprocatizing. Okay, I'll take one. Thank you. Hey, this is the same one I gave you. You know how I can tell the thing's sticking to the cough drop? Okay. Okay, so easy. In fact, if the graph is given for you, given to you, it's really easy to do. But like I said, you guys are gonna have problems when you have to draw your own graph. So you know what? Why don't I just take one out of the book, because you're gonna ask me to do it tomorrow anyway. I know you guys. See, you guys don't bring, look, did anybody even bring the book to class?
I have it. I do. But I'm
Anyway, next year, we had a meeting and then, next year, everybody's getting the e-text.
That would be helpful.
See, look, the beginning problems, they give you the graph so you know exactly which one's on the top and which one's on the bottom, or which one's on the right and which one's on the left. Okay, but look at this problem. Let's do a trig one. Did I assign number 32? I usually do. It doesn't matter because we're doing it.
Wait, homework goes 1 through 10.
Yeah, it's only 1 through 10.
I don't think so.
32 is on Thursday.
Oh, so we're spending 2 nights on this homework.
Yeah. But you can do it anyways. It'll help us out.
We can do it in one. Just kidding.
Okay, are you sure? Let me see.
It's 1 through 10.
I guess we're spending 2 nights on this homework then. Oh, so tonight's homework is just they give you the picture and then tomorrow night's one, you gotta start drawing your own. Well, what the heck? Let's just do 32.
Does BC use the same test?
What?
Does BC use the same test?
Yep.
So do we just like say we're all going to
Do you have the same homework too?
Pretty much. So
just use our own homework then?
Next
To do what?
My old
For
homework.
BC.
if you want to.
We used to.
Okay. X equal negative pi. Wait a minute. So you guys are 11th grade.
Yeah.
Since
Yeah.
when?
Since the beginning of the year.
What about before then? Oh, I didn't even know that. Now I know.
These are all.
Okay, do you guys even know? Do you guys even know what these graphs look like?
Oh no!
Okay, so same thing with BC. Okay, if you don't know what a graph looks like, usually they're gonna give you the endpoints, your limits of integration. So if you don't know what a graph looks like, what you do is you plot the endpoints and a point in between there. Okay, so like 1, 2, 3, 4. Okay, here we go. Let's look at secant squared. Plug in pi over 4. How long is this gonna take?
Oh, 2.
There you go, 2. Plug in 0.
Wait, to which one?
Secant squared, which is,
Oh, 0. 1.
so which one?
A 1.
Okay. Plug in negative pi over 4. 2. See, so you plot the two endpoints and a point in between, then the graph gotta look something like that, right? Okay, now what about tangent squared? Plug in pi over 4. That one's easy. I thought it was
One.
easy.
1.
Plug in 0.
0.
I thought it was easy. 0. Plug in negative pi over 4. 1, and then connect the dots. And then x equal negative pi over 4 is a vertical line like this, right? X equal pi over 4 is another vertical line. So this is the region that they're talking about right there. This is, every year, this is the problem. They cannot, you guys can't draw graphs. And by the way, on the problems on the homework that require graphs, I mean, you need to draw the graph, that's part of the homework. If you don't have the graph there, you don't get credit for this homework problem. Okay, now you have to decide, should I use vertical rectangles or horizontal rectangles?
Vertical.
How do you know?
Because it's
Because it's
horizontal.
Okay, I'll tell you what the key hint is. Look at the equations. If the equations are given in the form y equals something, that's a hint to do vertical rectangles. If the equations are given as x equals something, that's a hint to do horizontal rectangles. But you can also look at the picture. Vertical rectangles work out well. Why doesn't horizontal rectangles work out? Because when you do this, look,
Interrupted.
right minus left is the same graph. And then we have a problem there, yeah? So there's lots of clues why you should do vertical rectangles. Now, in BC, even though I tell them to do this, there's a few of them, I don't want to mention any names. Ishihara. They still don't want to draw in the rectangle, but the rectangle is the key to doing chapter 8. If you don't draw in the rectangle, you're going to have problems. How do you find the length of this rectangle? Top minus bottom. Which graph is on the top?
Secant squared.
Here, secant squared x minus the bottom. So top minus bottom, that's the length of the rectangle. What is the infinitesimal width?
dx.
Dx. And then we're going to add up all of these rectangles from
Negative pi over 4 to pi over 4.
Wait, were those numbers given?
Yeah, they were given.
Okay.
Because these graphs don't intersect, that's why. Sometimes they intersect, and then you gotta find the points of intersection. Other times they cut it off, and they tell you when to cut it off. Now, if you are smart, do I wanna do this integral from negative pi over 4 to pi over 4? Or since there's symmetry, can I just go to from 0 to pi over 4 and times it by 2? Right, because isn't this region the same as that region there? Because they're both even functions. What's an even function? Now, why is it beneficial to go from 0 to pi over 4?
Because you have 0.
Exactly, because most people have an easy time plugging in 0, but negative pi over 4 is scary, especially with trig functions. So that's up to you. It doesn't matter because it's going to come up. Strawberry, blueberry, cinnamon, whatever. Okay, now how do I do this integral? Here's the next problem.
Secant squared is on the list. Or you can separate it.
Okay, I'm hearing all things, and they're correct, but come on, use some body.
1 plus
That's 1.
There you go. This is 1. Let us review our trig identities. Isn't 1 plus tangent squared theta equal to secant squared theta?
Yeah.
So therefore, what is secant squared theta minus tangent squared theta? That's right, it's 1.
That's pretty good.
Wow.
Okay, now, I know what you're going to say, but Mr. Park, what if we don't remember that? Well, can you remember this? What's the only way in the world to integrate tangent squared? You got to replace it with the identity
Secant squared.
secant squared x minus 1, right?
Well, then you just add it.
And then what happens when you distribute that minus sign?
Oh.
You get 1.
Distribute the minus.
See, it doesn't matter what kind of Pop-Tart it is. It's going to come out. So, what's the antiderivative of 1? X. And throw the constant outside here from 0 to pi over 4. Factor out the constant. So you get pi over 4 minus 0. Final answer, survey says? Pi over 2. So this area is exactly pi over 2 square units. Yeah. Most students every year, they did chapter 8, they like chapter 8. Because you're actually using integrals to actually solve problems. So yeah, we're spending 2 days on this. So, and tonight, all the graphs are given, so there shouldn't be a problem. All right, we finished early. Oh, not that early. 14 minutes early, that's not bad. Look at here, you guys got 14 minutes left. How about like do like the first 2 or 3 problems, just to get the juices flowing.
That would be smart.
Oh yeah, that would be smart.
Or we could say.
Okay.
Or we could buy it. No,
Or how about start last night's homework? I don't want to mention any names,
Thank you.
but wait for a name.
Yeah. You
Sub-
always come out.